Hey guys, I'm Volnaiskra. I'm going to show you VACCiNE, which is something I made for Clickteam Fusion for my own use, and it's been super handy and super helpful for me. So I've packaged it up and I'm releasing it to the community, and hopefully it's going to be very useful to a lot of you guys too. It's essentially two components. You can use them independently, but they're very well integrated together. One is an input engine. It essentially makes using gamepads in your Clickteam Fusion game a lot easier and a lot more reliable. The other is a sophisticated debugging panel. It's kind of like the debugger that comes with Fusion, but it's in the game. It can do more things. It's a bit faster. Anyway, I'll show you now how it works. Okay, so traditionally to get a gamepad to work in your Clickteam Fusion game, you've had to use the joystick 2 object. There is an Xbox 360 gamepad object, but that's missing a lot of features. It doesn't give you much control at all. So the joystick object is pretty much what everybody uses. But it's really confusing to use. Different gamepads produce different results. They collect data in different ways. It's actually a real mess. In the left column here we see gamepad raw. This is essentially the data that the joystick 2 object is collecting. Xbox 360 gamepad here. So you can see I've got 8 directional movement. I've got 360 directional movement. For some reason 8 directional one is 8 when there's nothing going on, and 361 is -1 when there's nothing going on. The right joystick, well, that's sort of broken. Claims to be always moving left when it's not. D-pad starts at -1, but it doesn't start in the same direction. It starts at north instead of east, but it's there. Triggers go from, one trigger goes up to 995, another trigger goes down to -996. A little bit weird. The right stick, it doesn't give you directional movement at all, but it does give you X and Y axes from 0 to 65535. Now that's not rotational, so you'll need to use trigonometry or something like that to actually figure out the direction that you've got there. Now in terms of analog strength, you don't actually get that information from joystick 2. Like you can see, yes, how strong you're pressing something, but it's all hodgepodge. So for a start, I have to press the left stick a lot harder for a directional movement to trigger than I do for the 360 directional movement to trigger. On the other hand, the right stick has no dead zone at all. It's basically always moving. The tiniest little movements will register here. Now with the PlayStation 4 gamepad, things work differently again. Left stick is pretty similar. Right stick this time, we do have real data, but it works differently. So left stick starts at east, anti-clockwise makes the values go up. Right stick actually starts south. Anti-clockwise makes 360 degrees go up, but 8 directional go down. Weird. Now D-pad starts at north. Triggers are different. So on the Xbox 360, triggers are raw Z. On the PlayStation 4, triggers are raw X rotation or Y rotation. They've got nothing to do with rotation. Okay, so one of the things that VACCiNE does is it takes all of this crazy, nonsensical data that doesn't really match and doesn't always give you everything you need, and it makes sense of it. It makes it cohesive, logical, the same way for every gamepad. It gives you all the info you need. Whether you're using the left stick, right stick, or D-pad, they all start at -1 if they're not being used. If they are being used, they start at east and they go anti-clockwise, just like Fusion's default behavior. And you've got little icons that show you where the sticks are going, just because they're handy. And also you get the strength. I've added a dead zone, the same strength of dead zone for every stick. So the direction and degrees will give you the same sort of dead zone in the middle, and you can see the analog strength from 1000 to a 0. Same with the right stick, 1000 to a 0 dead zone, starts east, goes anti-clockwise. Same with D-pad, starts east, goes anti-clockwise. Left trigger, right trigger. Oh yeah, these little arrows will also show you if you're clicking the actual button, the actual pushing the stick. So the PlayStation, for example, works the same now. Everything starts at -1 for no movement. Everything goes from east to anti-clockwise, same with the D-pad. Right trigger, they all go from 0 to 1000. We don't have these crazy values like 65535 or -995 or any crap like that. Everything just works in a sort of sensible way. Okay, so basically any gamepad you plug in will work the same way. It'll give you the same consistent results for all the different sticks and buttons. Now that even goes for the Xbox One gamepad. Normally the Xbox One gamepad works just like the Xbox 360 gamepad, no problems. But on Windows 10 with native drivers, in other words, if you have a fresh installation of Windows 10 and you don't put any special drivers on it, you just simply plug in your Xbox One gamepad, it actually doesn't work. It joystick to object, and it's not just a joystick to object, but some other non-Fusion games have had this problem as well. Detects the triggers completely differently. VACCiNE will actually detect that and fix it automatically. So your player doesn't even have to realise that he's not got the right drivers. In your game, an Xbox One gamepad will work perfectly whether or not there are the right drivers or not. Okay, so that's already pretty easy. That's already a lot better. You've got every gamepad working out of the box and behaving in the same way. Values are simple, 0 to 1000 and that sort of thing. But it actually gets simpler than that. VACCiNE, you don't actually have to look at any of these values if you don't want in the gamepad neat section. VACCiNE takes them, combines them with keyboard controls as well into a very simple and easy to use universal input system. So basically we've got two regular active objects called VACCinput and VACCinput UI for user interface stuff. And whatever you press on a keyboard or any gamepad will appropriately register in those things. So we've got these alterable values for movement here. Movement left, right, up, down. If I move the left stick, I can make them trigger on and off. D-pad, same thing. Whilst on the keyboard, arrows. But not right stick, because you can easily put that in if you want, but by default right stick is made to not trigger movement because you might want it to trigger the camera instead, which is there ready for you to use it. But it will trigger the menu, because you probably do want the right stick to work in menus, as well as left stick, as well as whilst, as well as arrows. All of that stuff is already built in. All you need to do is look at the alterable values in these two active objects and just use these for basically the majority of the input in your game. Now, a binary press will be binary, so keyboard can be movement left 1, or if I let go 0, gamepad can be from 0 to 1, not 0 or 1. So you've got analog, same with the triggers. It goes to 1, but it goes to anything in between, depending on how hard you press it. So that makes it really easy to use analog or not to use it, up to you. Everything is from 0 to 1, and if you like, you can count the values in between as well. So the other half of VACCiNE is the sophisticated debugger panel, which you've already seen in the context of input. But it does a whole lot more, and it can show basically just about anything you want. It's kind of like the existing debugger panel that exists in Fusion, but it's just a lot more convenient because it's inside the game. You can toggle it on and off with a single key press or a gamepad press. It does consume some resources, but it is still a lot faster than the Fusion debugger. Here you can see how I've configured it for my game. Your game will be different. It'll be basically up to you to fill up this debugger with whatever information you want to track, but it's set up so that it's very easy for you to do so. So here you can see I've got a whole section for gravity, depending on whether Sprite is jumping or whether she's flying or whatever. I've got fall speed, I've got all sorts of different values for physics. Here I can see the animation that's playing at every time, what frame, the direction the animation is in, and just various sort of states that she's in. There's also a freeze frame debugger built into VACCiNE. So at any time I can press this key and I can cycle through frame by frame or resume it. and I can see how different things are changing. In my, this is great for debugging. This is great for figuring out what's happening when in your game. Lastly, down here we've got the benchmarking section. So the benchmarking section can live independently of the debugger. If you have the whole debugger on, it does take up a little bit of performance, as mentioned, so you can have just the benchmarking if you like. Okay, so in the benchmarking panel here, you've got frames per second, you've got ticks, in other words, how long it takes Fusion to do a single loop of all of your code, and a VAC score. A VAC score is something I came up with that just combines those things. So it combines average and minimum FPS and average and maximum ticks into a score that gives you a quick indication of how well your game is performing. It's not an exact science, but it's a bit more robust and accurate than simply looking at the FPS. Now you've also got these two tests that you can toggle on and on at will, and the idea of them is that it gives you this quick way to be able to stress test something or compare two different things and see how they impact performance. So in this demo I've got two fast loops, 1,000,000 loops each, so it's to really exaggerate and expose the performance impact of these things. Test 1 will turn something on and off by using visibility, so invisible/reappear. Test 2 will turn something on and off by using alpha channel. So for test 1 here, I'll turn it on. So it's 1,000,000 loops per frame, so it's obviously tremendously impacted the performance of the game. That's good, that's what we want. And it's measuring, so it's turning something on and off by using invisible/reappear. Now if I turn that off, so that showed me how my tick performance was then, 56 milliseconds per tick. Now if I turn the other one, and this turns something on and off using alpha channel. So now this is showing me the performance of that. And so I can see that it's actually not too different. It is a bit slower. It is a bit slower to use the alpha channel method, although not as much slower as I would have thought. But anyway, you can put anything you'd like into these two tests. It can be a good way of just, if you've got a feature you've put in, you think it's going to be a little bit expensive, put it in there, play a game without it, click the button, press the button, play a game with it, see how it compares. Or if you've got two versions of a feature that you want to know which one's faster, put one in test 1, put another in test 2. And you can compare. You can compare it also to the version to expand. In other words, the tick count that you had before the tests were running. So when the game was just on its natural state. At any time, we can reset all of that. And yeah. So here's what VACCiNE actually looks like. You've got all this debugger stuff here. These are the string objects that hold all the information that will be displayed. And then here you've got the joystick 2 object, which is used for just about everything. Xbox gamepad object, which is used just for vibration, not anything else. And then these regular active objects, which is where all the various information gets stored in VACCiNE. In terms of the event list editor or event editor, everything's in one folder here. So if you're putting VACCiNE into an existing project, you'll want to copy all of these objects and drag these into your frame, as well as one folder. If you're starting a new project, then you'll probably just want to open up vaccine.mfa and just start your game there. So I'm not going to go into great detail here, I'm just going to give you a very brief overview. Everything's well commented, there's lots of info here and on the forum, so yeah, I'm not going to go into great detail. But basically you've got the input section here, the text where the keyboard or gamepad is being used. Here it collects everything from joystick 2 object, and then here it translates that into neat values, section by section, left stick, right stick, Xbox, PlayStation 4. It's all well commented. It's got a logical sequence to it, so it's easy for you to, if you want to see what's going on. You can happily ignore it if you like. Here it will take all of that input and put it into those variables, so that the movement variables, the menu variables, the The D-pad, you've got three different styles of D-pad, one for movement, one for selecting items. It's all there for you to customize or switch on and off as you like. Different buttons, which keys they correspond to. It's all there, fairly simple. Vibration. So vibration is used using the Xbox gamepad object, because the joystick 2 object doesn't seem to work. And I've basically got 3 fast loops here. And you just call them when you want vibration. Vibration small, vibration medium, vibration huge. If you just call a fast loop to play once, you'll get vibration. Not on a PlayStation 4 controller, unfortunately. For that, you'll need an emulation program like DS4 to make your PlayStation 4 controller behave like an Xbox controller. Okay, and then there's the debugging stuff. So you've got the freeze frame debugger, and then basically all of your information that you want the debugger to hold, put it here. So this probably looks a bit scary, but it's just strings. It's just a string object, and you just put the string in here that you want. So current, gravity, and then these are the alterable values that I'm following. This just gives it a new line. It's just basically put whatever values you want. So mostly I'm showing just the alterable values of various objects, but the animation I've got it set up here, so that has to be done a bit differently. So I track which animation is playing for Sprite. You can do that with your own character as well. And basically just populate this with whatever data you have. Anytime you introduce a new mechanic, come in here, add another little piece, and the debugger will always be up to date and working for you. Custom tests, this is where you put the stuff in for your custom test that you can switch on and off. Basically put the title of it here, number of fast loops if you're using fast loops here, and then whack anything you're testing into this folder.